Okay, we're going to do some more examples using chain rule. So we've got chain rule written up here at the top. Derivative of f of g of x, so composition, one function inside another function, is the derivative of the outer function, leave the inside alone, times the derivative of the inner function. All right, so in this problem, this is a little more difficult than the examples in the last video. In this problem, we've actually got x a couple places here in the function that we're trying to find the derivative of. In one place, we have this x cubed function inside a tangent function. We're going to need chain rule there. But we also have an x squared out front. So if I read what this function means, it says y equals x squared times tangent of x cubed. So I'm also going to need to use product rule in this problem. And when I take the derivative of this second part, using product rule, that's where I will need chain rule. So we're actually going to be using product rule and chain rule in this problem. Okay, so dy dx equals, all right, I'm going to actually set up a kind of structure here to help not mess up the problem. So the overall structure of the problem is product rule. So I'm just going to set up some parentheses and write some little hints to myself. The derivative of the first function times the second function plus the first function times the derivative of the second function. That structure is chain rule structure. And then I'm going to think about where it is, that structure is product rule structure. And then I'm going to think a little bit about where I need to use chain rule. So where I'll need to use chain rule is where I have a function, an x cubed function inside another function. So when I go to take the derivative of that second part here, this is where I'm going to actually use chain rule. So I might have to extend this parentheses a little bit here. All right, so if you can write this structure out and even these little words to kind of give yourself hints about what you're thinking about and what the overall structure of the problem is, then you're just going back in and filling in the little details and you don't get so lost in all the details of the problem. Okay, so the derivative of the first function, derivative of x squared, is 2x, times the second function, just as it is, times tangent of x cubed, plus the first function, so that's just the first function in my parentheses here, x squared. All right, and here, where I'm going to take the derivative of tangent of x cubed, that's where I'm going to actually need chain rule, so I'm going to need to extend that parentheses a little bit here. All right, so when I do chain rule on taking the derivative of tangent of x cubed, I need to start by taking the derivative of the outer part. That's the derivative of the tangent. It's the outer part here. And the x cubed is the inner. Derivative of tangent is secant squared of, leave the inside alone, then times the derivative of that inner function. The derivative of x cubed is 3x squared. Okay, so here we have a problem where we use product rule and chain rule. This is our derivative. So if I don't need to simplify it, I could leave it like this. I'm going to go ahead and clean this up, though, and remove some unnecessary parentheses. So we have 2x, not equals, 2x times tangent of x cubed. And then this last part, after the plus, is all one term. And so I can go ahead and combine the powers that I have here. 3x squared times x squared is 3x to the fourth, then times our secant squared of x cubed. And there's our derivative. Okay, we're going to do another video using quotient rule with chain rule, so you can see that in the next video.